have mentioned this buzzword DNS many times before. In this video, we will study what it is all about. So DNS stands for Domain Name Service. But first tell me, how many identifiers do you have as a person? So let me get you started. There is your full name as appears in your birth certificate. I'm sure your parents lovingly call you by some pet name, Pappu, Bubbly or Chintu. And then there are your friends who also give you nicknames. Apart from this, what other identifiers do you have? Well, as far as the academic office at an institute is concerned, you are just a roll number to them because it makes it easy for them to process the student records. And then there are passport numbers, driver license numbers, so on. If you as a person have so many identifiers, these internet hosts that serve us are no less. They also have multiple identifiers. Two such identifiers are host names and IP addresses. You already know what IP addresses are. Host names, as the name indicates, are the names given to hosts. For example, www.facebook.com could be the host name of the Facebook's web server, and this is the IP address. So if you ask me to remember this particular string, it is very easy for me to remember, whereas I will have lot more difficulty remembering IP addresses. So host names are what are called mnemonic, that means easy to remember. They can be variable length and also they carry no information to help route packets towards them. So for example, if I look at this particular string, I have no idea where this host is located. Whether I have an idea or not is not important. More importantly, the routers have no idea where this host is located. On the contrary, the IP addresses are of fixed length, so this helps processing the strings very efficient at the routers. They are numeric and they also carry routing information within them that gives an idea to a router as to where this particular host is located so that they can send packets accordingly. So here is the problem. People prefer host names whereas routers prefer IP addresses. So we need a service that converts host names to IP addresses, and that service is the domain name service. In reality, DNS does more than host name to IP address translations. So it can convert host names as well as domains to what are called values. IP is an example of one such value. So we will see more of these values later. Let me also explain what a domain means as part of this domain name server. So a domain is a label that defines a realm of administrative authority. Facebook.com is a domain that contains hosts belonging to this particular company. Similarly, iitb.ac.in is a domain that will carry hosts belonging to IITB. So how does DNS work? This example shows. So for example, you are a user. If you type in your web browser this particular URL, what your web browser program does is it is going to call the DNS service and ask it what is the IP address corresponding to this particular host name. And this DNS service is going to get back with an answer that says that this is the IP address corresponding to this host name. And once you get this particular IP address, your web browser then is going to establish a TCP connection to the Facebook's web server by specifying to TCP what the destination IP address is. Before we see how this DNS service is implemented, let's first understand what are the services provided by DNS. As mentioned already, this host name to IP address translation is one such service. This is not the only service. It also provides what is called host aliasing. Alias basically means other names. You may have heard of this term in the context of these criminals who do fraud. They have a lot of aliases. So they use one name to cheat one set of people and they use another name to cheat another set of people. Well, DNS does no such cheating. In fact, it provides a very useful service via host aliasing. Sometimes in a specific organization, you may use the same machine to run your web server or your email server. But to the outside world, you want to specify www. Let's say ABC is your company's name as your web servers and let's say mx.abc.com as your mail server's name. But internally you are implementing this on this machine. Let us call it our.abc.com. So in this case, host aliasing is very useful. So what you do is you provide an alias to this which maps this particular host name to this our.abc.com, and similarly this also maps to our.abc.com. Another advantage here is later if you want to move this web service from this machine to some other machine, let's say ours.abc.com, you don't have to revoke this advertisement that you have already told others. Others can still access your web server by typing in this, except that within the DNS system you will change the mapping now to ours.abc.com. So here is an example with Facebook. So www.facebook.com internally maps to this particular host name. In other words, the web server of Facebook is hosted on this particular machine. The one you advertise to the outside world, this is called the alias host name. This maps to the star.c10r.facebook.com. This is called the canonical host name. Not only that, lot of these bigger organizations do something more. People can sometimes mistype the URL. So what they do is the spelling mistakes, like in this case Factbook and in this case Facebook, also map to this particular correct host name. So type this www.factbook.com and see what happens. You will notice that this indeed takes you to the correct website, even though you typed the URL wrong. There is another advantage of host aliasing. Suppose you are a small organization and this is your xyz.com, and there is another organization which is also small. Let me again call it abc.com. So these organizations are so small that they don't want to run their own web server. So what they do is they buy the service from some other server. Let's call it the server that is hosting these web servers. Let us call it service.com. So when you ask DNS what is the IP address corresponding to this, what you get in turn is the IP address corresponding to this particular host name. Similarly, if you ask what is the IP address corresponding to this particular host name, you also get the IP address corresponding to the same service.com host name. In other words, DNS maps both these entries to the same host name. Another useful service that DNS provides is mail server aliasing. Basically, it helps you identify the mail server for a given domain. For example, you compose a mail to me, which is chebrolu@csc.iit.b.ac.in. So the concerned program will notice that this is my domain and it is going to ask DNS what is the mail server corresponding to this domain, and the DNS will return this particular host name, which is jeeves.csc.iitb.ac.in, which hosts the mail server. As a consequence of this, I will resolve what the IP address of this particular host name is, again via DNS, and then I will send this email to that particular mail server. Similarly, this msgin.t.facebook.com is the mail server corresponding to the facebook.com domain. Yet another service provided by DNS is load balancing. I had mentioned this earlier. You normally don't run a single server, you run a server farm to handle the many clients. For example, when you type this www.google.com, which is the web server of Google, the incoming client connections could be directed to one of many servers. So the way this is handled by DNS is when you ask what is the IP address corresponding to this, it will give many IP addresses. And what DNS does, it is going to rotate this order of the IP addresses. So the clients normally act on the first IP address. In case they are not able to establish a connection to that particular IP address, then they take the second IP address, so on. So I will show this in action in an upcoming demo. So these are the services that DNS provides, but how are these services provided? Originally, in the very initial days of internet, the DNS service was provided through this file called host.txt. At that time, there were these different sites, and each site had many hosts, so there are many such sites. And there is a central authority. So what these site managers used to do is whenever they added a new host, they would contact the central authority and mention the host name and the IP address of this newly added host. And this central authority used to add this entry in this host.txt, and then it is going to send this file to all the hosts in all the different sites. So each of this hosts now have this file, and if you are establishing a connection, you just look at this particular host.txt file, which is local, figure out what the IP address is, and thereby establish the connection. Well, as internet grew, this approach definitely didn't work, so they needed to come up with another architecture. So what are your thoughts? How would you implement DNS? So one solution is, instead of the host maintaining this host.txt, what they can do is they can contact this central authority saying, give me the IP address corresponding to this particular host name, and this central authority looks at this host.txt file and gets back with the correct IP address. What can be the problem with this particular approach? You should be able to answer this by now. Well, quite a few. Whenever you use a centralized architecture, there is a danger of a single point of failure. If this central authority failed, the internet will go down, because DNS is a very crucial aspect of the internet. Without it, you cannot establish connections. Not just this, this particular central authority server has to cope with high traffic volume, because every host will want the host names and domains resolved. And also, where would you place this particular server, the DNS server that is? If it were in America, then all the people that are there will have low DNS response time, whereas people from India will have high DNS response time, which is again not desirable. Also, the number of entries that you need to maintain at this central node is going to be rather huge. That will lead to database maintenance problems. Overall, this centralized architecture is not a scalable solution. So how would you solve it then? Hierarchy to the rescue again. So the way the DNS is implemented is via a hierarchical and distributed implementation. So you have these DNS servers at different levels. At the very top level are these root DNS servers. There are 13 such root DNS servers. Each server is not an individual server, rather it is a cluster, and these root servers are managed by ICANN. You have heard this name earlier in the context of IP address allocation. In the next level are what are called this top level domain servers. There are quite a few of them: com TLD servers, org TLD servers, edu TLD servers, net TLD servers, so on. So this 6 are all based in the US, and these are country specific TLD servers. So IN stands for India, FR stands for France, UK stands for United Kingdom. So these TLD servers are again run by different companies. For example, VeriSign company manages this TLD server for the com domain. Below this are what are called authoritative DNS server. So for example, each organization maintains its own DNS server. So there is Amazon's DNS server, Facebook DNS servers. So these fall under the com domain because these are companies. And then there is Wikipedia DNS server, which falls under the org because it's an organization. And then there are educational institutes like MIT, Berkeley, which fall under edu. Let's look at this India zone. Within this Indian zone, there are multiple other zones. So there is CO to represent companies, AC to represent academic institutions, Gov to represent government organizations. So the IITB falls under this AC zone. And similarly, this MCGM stands for Municipal Corporation of Greater Mumbai. It falls under government. and the CSE department within IITB will fall under IITB. So there will be some authoritative DNS server that is being run as part of the CSE department. Similarly, IITB itself will have some authoritative DNS server that is going to handle the different departments. And this academic DNS server is going to handle the various academic institutions within India. Also, there are some that are directly connected to the India. So olx.in, for example. So as you can see, there are multiple levels of hierarchy. At any given hierarchy, there are different DNS servers. Another very important server is the local DNS server. So this provides the DNS service to hosts within an organization. So all the hosts within an organization will contact the local DNS server to resolve the host names. And these hosts obtain this local DNS server's IP address during boot time, typically via DHCP. So if you're in Linux, you can figure out who your local DNS server is by looking at this particular file. So how do these DNS servers interact to help resolve your queries? We will see shortly. So here is a map that indicates where all the root servers are located. Majority are located in the US itself. There are 2 in Europe and 1 in Asia. So this example tells how DNS works. Have you ever been to a government office to submit a file or get some information? What happens there? You go to one person and you ask him for some information. He says, I don't deal with this. Why don't you go ask someone else? So you go to the someone else and he says, no, I also don't deal with this. Why don't you go ask some other person? DNS does something similar, except that your query will very likely get answered, whereas it may not be in a government organization. Anyways, here is how it works. So here is the host which wants to find out what is the IP address of this particular host name. So what it does first, it is going to contact its local DNS server. So this is indicated by this message 1, wherein it will ask what is the IP address of www.facebook.com. Now this local DNS server is configured with the IP addresses of the root DNS server. How does it get the IP address of the root DNS servers? This information is widely available. If you are setting up a DNS server, you will have to somehow figure it out. Since it knows the IP address of the root DNS server, so this is the Japan's root DNS server. So it is now going to send this query to this root DNS server that is indicated by 2, and it is asking what is the IP address corresponding to this particular host name. Now what this root DNS server does is it is going to look at the string, and this string has a very specific order which captures the hierarchy mentioned earlier. So the root DNS looks at the last portion, which is the com. So it is going to reply back saying, I don't know what the IP address of this is. Why don't you try the .com top level domain server? And here is the IP address of this. So the root DNS knows the IP address of .com, not only .com, it will know .net, .org, .in, so on and so forth, and it is going to pass the IP address to the local DNS server. Then what the local DNS server does, it is going to contact this com TLD server and again ask what is the IP address of this www.facebook.com, and this TLD server is then going to look at this portion and it says, oh, this is Facebook, so I need to pass information about the Facebook's authoritative DNS server, and that's what it does. So this a.ns.facebook.com is the authoritative DNS server of the Facebook domain. So it will say, I don't know what the IP address is. Why don't you contact the Facebook's authoritative DNS server? And here is the IP address for this. And now the local DNS contacts the Facebook authoritative DNS server. Since this is the authoritative DNS servers, this will definitely have an IP address corresponding to this. So this gets back with the IP address. And once you receive this message, you then pass it to the host. The local DNS server passes it to the host. And you just thought you type in this URL and your web browser establishes a TCP connection to the Facebook's web server. As you can see, there's a lot of action behind the scenes. as many as 8 messages can potentially get exchanged. In reality though, the implementations are a bit more efficient. So what this local DNS server often does is it is going to cache the entries. For example, it may maintain a cache which specifies the mapping between the facebook.com web server's host name and the IP address that corresponds to this. So if some other user within this organization were to contact this local DNS server, it won't do all this. It will reply based on the cache. But these entries, like anything else we have seen before, have a time to live field, after which these entries are removed. Then again you will have to get the IP address by sending out many messages. Another thing these local DNS servers do is also cache this .com TLD IP address, .org TLD IP address, so on and so forth. That way they don't have to contact the root server always. So caching can happen at multiple levels. So we will break here. Up ahead we will see what are the entries that are maintained as part of the DNS server's database and how the entries got into the server in the first place.